Welcome. Hello. It's time for Blocktalk. We're on Bitcoin block 427138. Coming along here, coming up on our next difficulty change. Mempool's looking pretty good. But you got to remember here, we're coming to the end of the month, and that means there's going to be payments going out for everyone's paychecks. So looking for a little spike here. Anyways, we got some awesome sponsors to talk about. First off, it's Bittrex, where Storj coin is actually traded. There are a couple other locations, but if you like having your orders working in a very safe location, you got decades of security experience from the team at Storj coin, or from the team at Bittrex. Storj coin is pretty good too, though. And then, they got the awesome site here. They're rolling out new improvements here shortly, but they also do a lot more outreach in the space. They're one of the more, working with regulators and everything. Here they are. They're meeting with the U.S. Congress to kind of teach them about blockchains and how they should properly regulate it. So, you'll see a little guy from Bittrex over here. And we also have Syscoin. Syscoin is building a decentralized marketplace on their blockchain, including other things like identity, and they just had a new release here for a new company called Blockchain Foundry. It's kind of like the official company behind Syscoin development now, so they're definitely kind of taking a more legitimate means and solidifying the project. So we're really happy to have them sponsoring the show, and we look forward to having them on soon to hear more about Blockchain Foundry and a couple new releases. As usual, guys, if you have any questions, feel free to ask them in the chat. And yeah, we also have our live audience who will be drinking beers from the Bitcoin beer machine. So if you feel so inclined to send them $3 Canadian to buy them a drink, that's the address. I'll post it in the chat. Now, without further ado, hi, I'm Alex, and we have the guy who's dropping boxes and eyeing the cloud, driving Google crazy, the CEO of Storj. Welcome, Sean Wilkinson.
Hello, hello. I'm just posting this out to our Slack channel so everyone can hopefully join.
Nice. I bet that Slack's getting pretty big now that you guys are kind of getting close to rolling out the final MVP.
We've already hit the 5,000 limit that Slack has, and we have to cull about a bunch of users, and it's been a pain. So right now we're looking at using either Rocket Chat or Mattermost because it just doesn't scale. There's just too many people in there. We have one of the largest Slacks. So
yeah, that's absurd. That's good though. Lots of people, wanting to join the conversation and learn more and find out what the development's at. So I guess for anyone who's maybe not familiar, why don't you give a brief overview of Storj Coin and what you guys hope to achieve?
Sure. So do you want me to talk about Storj Coin or Storj in general? Because those are two separate things.
I guess you talk about the Storj network and then how the Storj coin plays into that.
Sure. So in a nutshell, what we're trying to do is distributed decentralized storage. We're building kind of a platform on top that's catered towards developers, competing with things like Amazon S3, Google Cloud Storage. At the beginning of the project, we were focused towards, building up kind of like a Dropboxy-like client, but as we progressed and learned, we said, it's better to build a layer on top, underneath, and build a platform where people can build many types of applications like Dropbox, Backup, all these next-gen platforms. So we're building a tool for developers to store and get data from the platform. Underneath, it uses a network of incentivized computers, so you can take your old laptop or your gaming desktop or your Raspberry Pi or a server in the back corner of a data center somewhere, and you can lease out that bandwidth and that storage space to the network. And you're paid for what bandwidth you lease out, what storage you use, and what performance level you provide versus other people in the network. So that's all available on our website, both the tools to put and get data from the website or from the platform, and also to rent out your hard drive space and your bandwidth. So that's all available on Storj. You can go register your account and download all the tools. I guess you also asked about Storj Coin. Storj Coin is just the mechanism and the token we use to buy and sell space on the network. So when you rent out your
Cool.
hard drive, you get paid in Storj coin.
So right now, I guess, is the size of the test net, or are you guys on the main net now?
Sure. So the lines get a little blurry there. So we're in currently test group C, which will actually be concurrent with kind of live launch. So we'll be continuing to do testing, but we will actually have people running, in that environment with live data. So that those two things blend together. We have about 7 petabytes available on the network. Last time I checked, I can actually pull up the stats right now. And we have 100 plus terabytes stored on the network. So total supply is about 7 petabytes. Total data stored on the total network is about 100 terabytes plus. So we're working on better tooling and libraries and APIs for people. So that should increase pretty drastically when we release the next fix.
Sounds like a lot of videos. So how does that kind of compare to, say, what a traditional data center size is? Like what a Google data center might store?
So let's see. I would have to go through and do some napkin calculations, but at the end of the day, if you were to store, I think like a petabyte last time I checked on like Amazon's cloud, that would cost you about uh, I think like 70 to $80,000. So you can kind of do rough math from there. I think data centers that Google and Amazon build are hundreds of millions of dollars like data centers. So pretty sure they have more than a few petabytes in there. But this is probably the size of
Yeah.
a small data center. But they vary in size. You can have small ones that are like a shipping container and giant, $100 million ones that take up a whole warehouse.
Oh, you're getting a little choppy here. I might ask you to turn down your bandwidth slightly on the call. But
Sure.
I guess my next question would be, are you guys kind of geared towards, business who might be having, several thousand terabytes of data, or are you trying to do the more consumer end with just, mom and pop backing up like a gigabyte of photos, or are you doing everything?
So right now we're focused kind of on developers and building tool sets for people to onboard data. So, um, for example, you might have someone who helps us and builds out a Dropbox-like client, so people can store their pictures and their videos and their movies through that. But you also might have another use case where they need to back up a lot of video data, and so they're using a custom tool, to be able to store, 100 terabytes of data. So it's really the whole wide range, right? We're a platform, so you can access the platform through many different means: application, via an API, via command line tool, via an Explorer. So we're really trying to do the wide range there.
Cool. So you guys have any, I guess, big developer platforms that are interested in kind of using uh, using your back end for their front end? Like, are there any notable front ends we should be hearing about yet, or everything's kind of
Well, there's limited stuff I can discuss, but we are talking to and working on a pilot with Bell Transportation. So they have a lot of video data that they have to kind of store for insurance and regulatory purposes. So they have a ton of data that they send to AWS. So we're working with them to kind of bring that down and provide them with a better performance and a better solution. So that's one example. There'll be many more that that we will post, but we're kind of back and forth. We are very privacy oriented, a very security oriented company. So there will be some use cases that we'll push out there so people can get a better understanding. But generally, we want to not talk too much about our customers, just because of privacy and security portions. So.
Oh, come on. Don't be holding out on us. We want to hear all the crazy big names. Oh, we got NASA. They're putting all their crazy scans of planets. They want it all to be backed up on storage.
We wish. Maybe later. But right now we're just focusing on developers.
Okay, so
The platform has been open for about 3 months. We have about 5,000 users signed up, and they're kicking the tires, and we're building out the tools that they need to, get where they need to go. So shout out to Bell. They're one of our coolest use cases.
Nice. Well, so I guess dealing with privacy and everything, you guys are probably having to look at what are the regulations for holding other people's data. I mean, you're not per se holding them, but you're definitely providing a means for storage of data. So how are you guys working with regulators, and what sort of challenges have you overcome?
Yeah, so the laws around data security and privacy, are pretty, I think pretty, well written and understood. It's just kind of the education process. Okay, how does this existing law apply to us? So we spent a lot of times, and my co-founder James Presswich spent a lot of times with our very, very smart lawyers, kind of working through that problem and seeing how that applies. So we feel like we have a pretty good framework around existing regulations, dealing with privacy and security of data as it relates, to the United States. So we feel we have a pretty good handle, and that's reflected, in kind of the legal documents on our site that you can read. If you like reading terms and services and privacy policies, they're there, and they kind of, cover that in depth. So we think we
Yeah,
have a good handle. And we made some adaptations to our system, to handle that. So one thing that makes it easier for us is that all the data is encrypted, and it actually doesn't even flow through, storage lab servers. It's transited directly to people who store the data on the network, but in an encrypted fashion. So we can't even read the data, or see what it is, because we don't have the encryption keys to that data. So that makes it a lot easier for security and privacy policies, because again we can't read the data, so we can't really mess up or do anything there. So that's one thing that's cool about the technical design of the system, is that we can't mess up. If we get hacked, it doesn't matter, because again, to the data, we're just helping route encrypted shards. So
yay, client-side encryption.
yeah. Yeah, unless someone breaks encryption, but then, that's a whole different problem. There's a lot worse things that would happen. The nukes would launch. People would break into all the banks. The least you would worry about is, someone getting access to your files on storage. So,
What kind of encryption do you use?
so it's completely flexible. So we are using the generic, crypto libraries, through OpenSSL, so you can pretty much plug and play any encryption algorithm you want. It's kind of the up to the end application, and end user. You say, I want this encryption algorithm over another. You can set that as long as it's a standard encryption.
So do you guys have like a default encryption that's like already there? Like I'm kind of curious if you friendliness.
It's Mac 256. I'd have to go back through the docs. I'm forgetting now, but yes, we have a default that we use. I just have to remember. I'd have to look through the code. I'll come up with that towards the end.
Okay. So I guess that being one of the options that you guys can have, you must have like a bunch of different slider bars on the plan of redundancy and latency time, and there's a lot of different characteristics you can have for your data. Can you kind of talk more about those features?
Sure. So in terms of redundancy, that's something that you can set in the tooling or in the API. So for example, if we're talking, for example, like the command line interface, when you're uploading a file, you're just doing, dash redundancy, and then you're adding, how much redundant copies you want. So by default, you might want to do 3, and that might be good enough for you. Or if it's, something really, really important, you might want to do 12. So that's really up to the user on what redundancy they want to use for their specific use case. That's all open for them. So obviously we have some defaults in there, but again, that's all open to the user based on their use case.
So how likely is the data to get lost if you use the defaults? What's the
so ideally it should be 0, but it actually ends up we're aiming for 7 nines of uptime in terms of the data. So what happens is there's 2 ways you can treat redundancy. One is you're taking this data and you're just storing multiple redundant copies. So you could set 3, 6 redundant copies throughout the network. We have a very efficient way of doing that we just call mirroring. The second way that we're more gravitating towards is you actually take that data, you break it down into smaller little chunks with parity chunks using an algorithm called Reed-Solomon iteration. So if you're familiar with something like RAID, it's somewhat similar to that, where you can use like multiple pieces in that structure and the data still be all right. So we're gravitating to use default, which is 20 of 40, which simply means I can lose any 20 of the 40 pieces. Well, I can lose 21 of the 40 pieces before that file will be lost. So we're constantly checking to make sure that all pieces are available. So if a computer was to fall out of the window or there would be some network issue, we'd say, oh, piece 39 or 40 is down. Let's take these extra pieces that we have and now copy them somewhere else to recover that redundancy. So it's self-healing and self-recovering in that manner. So there's kind of 2 options to do that. And once you get into kind of this Reed-Solomon with the different parameters, you actually get a very, very, very robust system, more robust than, say, Amazon S3 or any of these other platforms.
So, Sean, I've been wanting to get off like Google Drive for a while now, and I just kind of want to set up my own little cloud, I guess. Is that something I could do today if I had Storj coin?
So right now, like I said, we're kind of focused on developers to build out many applications, like a Google Drive or a Dropbox replacement. So right now, the tools are more geared towards an API and a command line tool, which is all kind of nice, draggy droppy like Google Drive. But we do have graphical clients in the works.
Did you guys have some graphical interface at some point, or?
Yeah, so it's actually in the roadmap, and it's also being worked on right now.
Okay.
So there is a community member by the name of Nutterzuck who's working on a Java GUI right now. You can play with it. It's still in development. He estimates that it's probably going to be another month and a half before that's more stable than you can use. We've also are looking at essentially making it so you could just use storage as a mountable drive, so it'd show up as a the S drive on your computer. So we're actively right now working on those types of solutions just to make it easier to use.
But so if I was comfortable on command line mode, is this something I could do on the command line? Like with Google Drive, I think they give you like 15 gigabytes of data which is like peanuts. Is this something like if I do have this set, like the skills, the command line skills, I could do?
Yeah, I mean the command lines is pretty simple. Depends on what platform you're using, but it's like the shortest is you paste in 2 commands and it's installed. Then you just log in and you can use the upload and download file commands and all this kind of stuff. So you can look on our website. There's a quick start guide that shows you how to set it up and how to do the basic commands. So if you're comfortable with command line, you can try that out. And Google Drive gives you like 15 gigabytes, kind of peanuts. We actually are giving people unlimited storage as of now for completely free because we want people to kick the tires as much as possible. So people are using it, playing around with it, finding bugs and sending bug reports, but it's an open playground right now, and I highly encourage people to play around with it. It's no cost and nothing off your back to try it out.
So currently, you need storage online.
So now,
sorry, I just said, do you need any storage coin to have access to it, or is it just?
No. So what we've done is for the people who are storing data on the network, we've kind of abstracted the network itself and storage coin. We're catering towards general developers who want to use just a storage platform. So you pay $1, for X number of gigabytes, and you can push and pull data. You don't really have to worry about the blockchain aspect and all those other things. That happens, but it happens behind the scenes, and we take care of that for people who are storing the data on the network. It's different for people who are renting out their hard drives. Obviously, they're paid in storage coin for that.
Cool.
so yeah, you mentioned you're kind of offering, you want people to kick the tires. Have you guys had any kind of, I guess, malicious attacks, or you've gotten a phone call in the middle of the night, like, oh God, what's going on? Let's see what's happening.
Not necessarily malicious attacks as we've seen, or not that I can remember. It's a distributed network, so those things are generally pretty robust. I mean, you look at Bitcoin and blockchain. How much downtime do you think that's had in the past, let's say, 7 years? Anyone want to hazard a guess?
Well, it depends how full the mempool is, I guess, or how low of a fee did I set.
That's true. There's times when you're having trouble, getting transactions, but it still works. The only issue that it's really had was in 2010, sorry, when they had that hard fork, the emergency hard fork that they had to do, and that was resolved in like 2 hours. So distributed networks are very, very robust to disruption and attacks. It's more as you scale these things out, we learn, oh, we're actually need to make this optimization to the protocol because it sends out too many messages here and things are getting clogged up. So it's more optimization problems than necessarily people trying to attack a distributed network, which doesn't work too good. So they're generally pretty robust.
So in terms of correlating, data being proved as stored versus a payment for that data, like how are they distributed fast? Is it client side? Is it kind of a smart contract similar to like these other networks you've seen, or like how is that kind of payment being sent?
Sure. Can you repeat the question? You cut out a little bit. I want to make sure I got all of it.
How is the correlation between data being stored in a hard drive and payment being sent out? Like how is that proven triggering that private key to send?
Sure. So I guess I'll kind of step you through the process of what that kind of looks like. So first, as a user, you sign up for an account on Storj. So let's say you're a developer building the next awesome Dropbox killer. that's more private, secure, and faster. You sign up for an account on Storj. You sync your tools and your environment. You generate a key pair, just like a Bitcoin key pair, and you use that to authenticate with the service. And so now you have files you want to upload to storage. So the way it works is you take the file, you break it into small pieces locally, you encrypt those pieces with only keys that you know and have access to. We don't know, third parties do. You just have access to that. And then we help you determine where to put those on the network. So we have information about many different peers on the network. This guy is great, he performs great. This guy is on dial-up, he's really slow. So we say, hey, these are the people that you should probably send it to, and we give you authorization tokens for that, and so you send it to those peers. So at the end of the day, you get a bill at the end of the month. This is how much data you've transferred on the network, and you pay us for that service in dollars. On the flip side of that, the users, the farmers who are storing this data, they're both serving the data, they're transferring on their bandwidth when it's requested, and they're also storing this data over time. Now, the way that works is that we're constantly auditing those users to make sure they're available and there, and they haven't modified the file. And at the end of the month, they're going to get paid for the aggregate of what they stored. So they might be storing data from 1,000 different users, and they're going to get paid for storing that data. So the amount that they receive really varies from month to month. They can be, it highly varies based on their bandwidth, how much data they store, what data they stored, and how much it was accessed, and how frequently it was accessed. And also, you have to factor in there's other users in the network that might be out competing you or providing less service than you, so you'll get more or less contracts over time and more or less service over time based on that. So that is highly variable. Right now, that goes out.
So I was just kind of curious because it sounds you said you're giving out authorization tokens. So this isn't exactly an autonomous network. Like you guys are kind of you're matching customers with clients in some sort of fashion, right?
So the authorization tokens also exist on the protocol level. It's just a way of having a one-use kind of authentication with someone who is trying to store the data and someone who store the data on the network and someone who is storing that for that user. It also can be used as a method of security and who has access to what files. So what we're doing as our service, so for example, to be clear, this is all open source, all decentralized, all runs on top of a peer-to-peer network. What we do at Storj Labs is abstract that a little bit, right? We turn that into you just push and pull data. That's what it looks like on the top level tool set. You don't have to worry about the authorization tokens, which farmers to choose, whether they provide good or bad service, the payment, the auditing mechanisms. You don't have to worry about that. All you worry about is pushing and pulling data. And we take care of that behind the scenes. Now, there's specific use cases where people might want more control. Then they can dig under the hood and mess with payments, mess with authorization tokens for authentication. And again, it's a completely open book. It's a completely open platform. But at the end of the day, to start, you probably just want to push and pull data, then start to add additional functionality as your application needs it.
So I guess you guys are the training wheels for the network, but like Storj could disappear, Storj Labs could disappear tomorrow, and the network would still be functioning. It's just you guys are kind of, I guess, filling a void of reputation. I guess would be my understanding of it. Like,
less reputation, more simplifying some of the necessary steps in terms of the platform, providing help, documentation around it, and also we're in this network, helping establish all these relationships between, different farmers and people who are storing data. So we get a lot of information about that. So we can say, oh, we had this relationship with this guy, and we transferred, thousands of, data items between him. So we know his performance. We know he turns off his computer between 9 and 10, every day. And so we know that information because we've had that relationship with him. And so we are the best people to help abstract some of that and make a very fast and quick service for people, whereas if people did them themselves, they would have to do that. So again, it's an abstraction layer. You can go on local bitcoins and trade bitcoins for cash. That's great, and that works, and that has a lot of use cases. But the majority of people just want to go to Coinbase, click a buy and sell button, and be done.
You mean they want to go to Bittrex? Right?
Yeah, or Bittrex. Or Bittrex.
No, but I think that's good. Like, you want to make sure people have the best experience possible.
Right.
If like, oh man, my latency is so terrible, I'll never use this again. Damn distributed networks. Well, like maybe it's just they use the wrong settings or something, and oh, you're actually storing files in Russia. What are you doing? You should be, on the other side of the state, not the other side of the world.
Right.
So does geolocation actually play into it at all, or?
Yeah, so we're collecting kind of data around that, and that's something that we kind of want to offer through the tools later on and through the API later on. Probably in the next coming months is like, okay, I have this data. It's really popular in New York, so I want to serve. I want to get a bunch of farmers in New York, and so we can help facilitate that. Help get what are the best farmers from your use case. And there's two ways we can do that. One, we can do that via you setting a flag, right? You say, I just want a bunch of farmers in New York. Okay, here it is. Two is that can happen a little bit more automatically, is that as requests come in, they notice that they're coming from, this location. So maybe we should move, some of that data to that location where we're being requested. And so that's one of the powers of a distributed decentralized network is this optionality. Like, if you're getting your data from Amazon, like they can't move the data center closer to you. But for a distributed network, the way that could work is like, oh, I see these requests are coming from here. Let me choose the farmer that's actually like 3 buildings down from you. And so that's very quick, service and performance because they're so network and geographically close. So
Far
those are
more flexible.
Yeah, it's a lot more flexible. Both, using that to get better performance, but to get also better resilience and robustness than more typical networks.
Now, speaking of other networks, I know another one that's very close to launching here is MaidSafe, and they have a very similar aspect of kind of decentralized data storage. Can you kind of talk about how there's the differences between storage, maybe pros and cons of your system versus theirs?
Yeah, so MaidSafe is a bit of a broader subject matter. So they're trying to do, the whole decentralized web, email and all these other things. We're specifically focusing on one vertical, which is storage. And so their scope is a lot broader. So they've been around since 2006 working on this kinds of stuff, and the whole concept. So yeah, I played around with their alpha. It was pretty cool, but right now, kind of they're in kind of alpha stage, and they're running all those nodes on DigitalOcean. So it's very cool to play around with it, but I look forward to seeing what they come up with in the next few months. But it's definitely an interesting concept and definitely has some cool use cases.
do you see any kind of interconnectivity of storage? Like, say, storage is actually cheaper to get data, and then I can use a storage node to host my MaidSafe node, and then I make a little bit of a cut there, and there's maybe
Yeah. The way I see it is, a lot of people see, MaidSafe or some of these other storage projects as like competitors, and I really don't see it that way. It's like, is TCP a competitor with UDP? Is like not really. They're two different protocols that have, two different, really use cases, and you use them based on, what's best. And sometimes, they work in parallel and work together. So that's the way I see it, is that, maybe in the future, as these things mature, there's more interoperability between, multiple decentralized data storage platforms.
yeah, and I imagine like some people find a way to maybe market it more, like have like a shopping cart or a site where you can see the difference between AWS and storage. And that's the kind of tipping point where it's like, well, it's not a matter of you guys beating Maid or Maid beating you. It's more just like, let's get to a better system. So it doesn't really matter who succeeds, right? Now, something else that's kind of popped up recently in the crypto space is Kim.com has been making a lot of noise with his Bitcash or Megadice or whatever it is. It sounds like a lot of transactions on the Bitcoin chain, and he really needs, Lightning Network for it. But I'm just curious of your thoughts of, or what you've been hearing or about Kim.com's project of trying to do some sort of data storage of some sort on Bitcoin blockchain.
Yeah, it's definitely interesting. Mega Upload was pretty cool. I think I look at it more from the technical perspective of, wow, they did a really good job of doing, in-browser uploads and downloads and encryption in browser. I thought that was, like, when I played with that for the first time, I'm like, whoa, they've really done it well. So I'm interested to see what he comes up with. I'm more curious, I think, on the technical side, like, how is this going to be different? How is he going to accomplish, what he set out to do with Bitcash? So I look forward to hearing more about it.
Cool. Well, glad to hear your thoughts.
I'm supposed to talk with him at some point, but that hasn't been confirmed. He's been kind of busy.
Maybe Bitcash is just a front for storage. It's like, yeah, we got this amazing thing. You're gonna have it all in the back end, and it's like you're gonna get Bitcoin micropayments. And meanwhile, it's just like, oh yeah, Sean, just like let me port data into your chain here.
Yeah. Well, I mean, we'll see. I mean, we've been working on this for a while, and we're scaling up.
Yeah.
You can use the platform now, so.
Cool.
Anyone who wants to build on top, whatever it is, we're an open platform, and we want people to use it to build whatever applications their heart desires.
Yeah. So speaking of developers wanting to build applications, I think Taylor has a question. If you Decontrol wants to unmute.
So I just want to make sure you're understanding what you're saying. If I'm a company or a developer that needs a need for storage, I can come to your private company and pay you in Canadian or US dollars to store my data. Is that correct?
Correct. So we want to make this as easy as possible for you. Is that you pay in dollars for the gigabytes that you use to store and the gigabytes that you use to transfer.
So I would pay you in traditional money, but what you're selling is a distributed resource. So you're selling what's on the network, and you're paying the people who are actually posting the data with storage coin. Is that correct?
Correct, because at the end of the day, we can't take a US dollar or a Canadian dollar and split it into 1,000 pieces and pay 1,000 of a cent, to different farmers on the network. Like,
so
if
how
you
much
do an ACH transfer for
storage coin does your company have?
So we started in 2014. I guess this would be a good segue to talk about kind of storage coin and how it operates and how it works. So we created about 500 million storage coins. Of those, 50 million were sold in a crowd sale. Actually, more accurately, it would be 47 million. We've used approximately 2 million a year. So that's inclusive of what we're paying out for test groups for people, storing test data and giving a lot of information on how we build the system, and then also going out to community volunteers to, build the binaries for the installers and provide support and all that kind of stuff. So actually Monday, we're releasing a transparency plan. This is, I think we've dropped some hints about this, but we're releasing a transparency plan, our first transparency plan on Storj Coin, to give people a little bit more idea of the underworkings of how that works and how the distribution works. Because at the end of the day, there is no mining in the counterparty protocol. And so we created, the Storj coins. We had the crowd sale, and then we have, all these coins left over. It's like, how do we, fairly distribute that, and how do we be transparent about that if there's, no way of mining or these other things to distribute these tokens. So I'd look for that. If you want a little bit more information on the tokens and how those operates, look for our first transparency report on Monday. We'll also be doing more reports that go and dive in deeper detail of how that works and how it's been used so far to date, and how we plan to use that in the future to support the ecosystem.
Cool. Yeah, I'm glad you brought that up, Taylor. And yeah, that was, I guess, one of my main questions, because it's kind of like you have 90% of coins are not even in circulation right now. Yeah, I'd be really interested to hear. I'll definitely retweet that on Monday. But yeah, if you guys are going to be burning any, or if you're planning on, I think last time I talked to you, you said you're maybe going to have use it to put data onto the network, like say like Google wanted to, put some of YouTube on the network.
So the way that's kind of architected as of now, so we this is a distributed data storage network that works like a marketplace and is incentivized by cryptocurrency, and so it just creates like these whole new like set of economics and issues that like no one's tried before. And so we kind of realized that, and we brought on a PhD economist, Warren Weber, who has 30 years experience in economics research and monetary policy, and he's been helping us like draft how this should function and how this should work properly. Because again, you have these people who have misused supply and done all these kind of crazy things with tokens, and we're rational actors. We want this to be used in the most efficient way possible to provide value to everyone, not ourselves. So we've been working with him to like craft that and solidify that and make some rational choices around that. So again, that comes out Monday.
Cool. Some questions just on counterparty and kind of how this functions. So you guys own the ticker of SJCX, right? So like you guys have the rights to I guess can you create more tokens? I guess is the roundabout thing I'm trying to ask.
So the way we structured it, so we don't necessarily own the ticker as much as Satoshi Nakamoto or Charlie Lee owns Bitcoin or Litecoin. That's just the name of the token. So the way it works is, in 2014 when we were starting this, we said there's 500 million Storj coins. So we created those. We have them in a multi-sig wallet, and then we lock the token. So no more can be created. Once you do that operation, once you lock the token, you can't create any more of the asset. That's the way the protocol works. So no more than the amount that we said at the beginning of the project in 2014 can be created technically.
There's the mute button. Okay, cool. Yeah, no, that was kind of my question. We'll dive deeper into counterparty on a future show. I have holding coin and counterparty coming on.
Oh, it's a deep subject, man. On markets and cryptocurrencies and what we're doing differently from some networks. So one of the things we hope to do is actually be one of the first, projects that implement and use micropayments at scale. So we've taken some really cool stuff from Lightning, boiled it down into something as simple as possible, and that runs on, Counterparty, which for people who don't know, Counterparty is just a meta protocol on top of Bitcoin. So we do not have our own blockchain.
Yeah,
We
that
run
was kind of my next question too. On like, so if you're doing micropayments, you're still subject to Bitcoin's network fees, right? So like, how do you guys do that at scale?
So this is actually one of the primary reasons why we haven't, burned a large number of tokens that we have, is because we can actually use those tokens in payment hubs. So I guess I have to break down a little bit how micropayment networks work, which is fun technical stuff. But the way it works is you can avoid paying massive fees by creating channels and leaving them open for long periods of time. So, for example, if I want to make a Bitcoin transaction to you, and let's say it's like 50 cents, I have to pay a transaction fee for that, right? So I have to pay, 5 cents or whatever for that, 10 cents for that transaction fee. So if I want to send you like 10,000 transactions, that adds up to a lot of fees. Now the way micropayments work is, and the particular type that we use, hub and spoke, is that I open a payment channel to a hub, and then you open a payment channel to that hub, and we leave those open. And so if I want to send money to you, I send 1,000% to the hub, and then he sends out 1,000% to you through these open payment channels, and you tell me you received it, and then I can, continue sending, those payments till we're done. I don't have to trust the payment hub with more than 1,000% for like 10 milliseconds. So if he's malicious or whatever, it really doesn't matter because it's, again, 1,000%. It could be a Satoshi, it could be less.
So is this the Lightning network you're talking about, or is this something that's implemented right now?
This is micropayment. This is a type of doing micropayment channels, micropayment hubs. One system that is implementing something like this is called Lightning. So I'm talking about the abstract concept, and the network that's actually implementing something like this in code is called Lightning. And we've taken some of the primitive concepts of both this and Lightning and built our own kind of simpler version called Pico Payments. And so that's in development, and we hope to roll it out. So back to kind of the Storj coin thing is, to have those open payment channels, you have to lock up a large amount of funds to make that work. And so what we can do is we can actually take, I'll back up. You might want to store like $5 of data, but to make that work, you actually have to have a lot more funds kind of locked up in limbo. You might have to have $30 locked up. So that's not really fun. So what we can actually do is we can just drop these coins on these payment hubs and use those coins to be locked up. So when you pay out $5, you're just paying out $5. And these coins help provide, the best word I can think of is liquidity, so you and I don't have to pay excessive fees, and the network works a lot better, a lot more efficiently, and a lot smoother. So that's how that kind of works.
Cool. No, I'm excited to kind of see it implemented, and definitely how that's going to go further along.
Explanation of micropayment channels, which is still something that's in development. It's been demonstrated, but really hasn't been, put into an application that we all can use and scaled out. So there's some blog posts and white papers you can read on, our blog and information about that. Very much something that's new and in development.
Oh yeah, I know. I've definitely seen some readings already of Alice and Bob in a grocery store and a coffee shop and all that. Trying to, I guess, do it more in a graphical form, which is probably better than us explaining it here now. But let's kind of go back. I guess Taylor's got another question. Of course he does. So let's hear what Taylor has to say.
Hi. Um, so counterparty transactions are like built into the hash of the Bitcoin transaction, right? I don't think it's possible to watch for a counterparty transaction the same way you can watch for a Bitcoin transaction on the network. Like Lightning requires the ability to invalidate old transactions in order to work. On counterparty, that wouldn't work.
Right.
So you have to be able to watch the network and be able to see the transactions on the network and then see somebody's trying to broadcast them in the state.
If you want to reverse the direction of the payment channel. Right?
So you're completely correct in the way that it functions now. There is actually new opcodes. So as of now, you could not implement that based on the way that works. But they're adding, opcodes that are more, things that have been merged into Bitcoin, like, pay to script and all these other things, pay to script hash, which would enable you to do this correctly and trustlessly in the way that Bitcoin already does it. So there are some issues with the current way that it operates, but the opcodes that will be added during development would actually fix those issues, and they would work exactly similar to the way you do micropayments, or very similar that you would do micropayments in Bitcoin.
I got a question.
Can you ask a question?
Can you talk about the economics, like sort of supply and demand? If I attach a drive to the Storj network right now, will it start filling with data instantly, and to what percent? Like, is there excess drive space? What kind of overhead in the network is there in terms of, like, if you look at Storj as a giant hard drive, what percent full is it? And are you managing that sort of like a central bank by issuing tokens to try and sort of encourage the price to stay down? I don't know how you encourage the price to stay up. But.
So we're only paying, in previous test groups we paid for, just how big your hard drive is. What we're paying for now is how much data you store and how much bandwidth you transit. And so it's a very early network, so there's not a huge amount of data that is being stored. So generally, if you were to connect now, you would start getting contracts and data pretty instantly, but it would amount to maybe a few gigabytes or a few dozen gigabytes of space on average. So as the network grows and as the demand grows, there's more available contracts and data out there for people to have. So on the low end, people are storing a few gigabytes, but for an optimized setup, I've seen people store, anywhere from 100 gigabytes to a terabyte in some of the higher cases. So it's really based upon kind of where you are in the network, what's the performance of your hardware, but also what's the demand on the other side. How much people are actually storing data on the network to be able to land on your drive. So it's still very early days in terms of demand and usage. Those tools have only been available for the past 3 months, and so we're continuing to add tools to make that easier for more people to put more data on the platform. So in summary, it's going to be small right now, but it will grow over time as the platform grows. Did that answer your question?
It sounds like if I have like a multi-terabyte hard drive and I attach it to Storj right now, it'll pretty much just sit empty, and I won't be able to like earn based on that size of the drive. It's just I'll get my 1 gigabyte share, and then the rest will just sit idle. Is that correct?
So it highly depends on kind of your setup and where you are kind of distributed in the network. So if you were to take the time to really configure it, you can start to fill up that drive. But again, the ranges I've seen are anywhere from a couple gigabytes to about a terabyte. So if you're talking like putting 8 drives into a chassis and try to fill it up, it's not going to happen because there's so many other people in the network that are going to get part of that data stored. So I'm trying to think of a better analogy. Is that if you have 40 apples and 1,000 other people have 40 apples, but at the end of the day we're only trying to buy 100 apples total, we're only going to take one of your apples. So the demand has to come up for that to grow. At this point, I only recommend people like taking their extra laptop that's sitting in the closet and use that. I don't recommend going out and buying 10 server racks to try to earn money, just because there's so much. Everyone has extra hard drive space that's free and available for people to use. So the data stored to data available disparity is huge, and probably will always be that, because again, this is a free as air resource that everyone has compared to the other alternative.
So is there a bit of a queue, I guess, for like people to get filled with data? Like, so the longer I'm up and waiting for data, the more likely I am to get filled over someone who just plugs in online, or I guess it depends on.
So it's kind of determined, kind of in 2 ways. First is that you are on a what is called, it's a distributed network that's based on a distributed hash table called Kademlia. And so basically, you join the network and you're given an ID. Think of it as a Bitcoin public and private key pair. And based on this node ID, you have particular neighbors that you are close to, not necessarily geographically, but in this abstract network, you're close to these users. And so this data will be shuffled based on its content to these different regions in the network. So you might be close, like not geographically, but in network terms, to a place that is pumping out a lot of data. So you might get a lot of data and fill out your contract, your hard drive a lot quickly than other people. So that's kind of the first metric. The second metric is, over time, we're tracking metrics like your bandwidth, your speed, your latency, all these other, your geographic location. And so we might say, hey, you're actually close to this guy who wants, who's getting, data in, Toronto or something like that. And so we're going to choose you over other people based on your metrics. So it's just about being in the network, providing the best performance that you can, and you're going to get picked for specific use cases. The other things are going to be based on network size, demand, and in some cases luck. We have a complete write-up of how this works on a higher level on our blog. There's parts, how storage works, parts 1 through 3, that goes into a little bit about how data is chosen and how farmers are chosen.
Yeah, if you're definitely
reading, that's on our blog.
If you like the blockchain, you're gonna love hash tables.
There's so many fun technological concepts and primitives that I could get lost very easily and bore quite about everyone talking about them. So stop me if I get too deep, because it's fun for me. But some people just want to store data and not hear about me ramble about hash tables and all that kind of stuff.
Well, we're getting close to the end of the hour here. Let's. I got one good question here. Is like, where do you see Storj in 5 years? Like, well, what's what's the future look like?
I think it's similar to something Satoshi Nakamoto said. Is like 5 years, it's either going to be very large and very big, and most of the data in the world, or a good significant portion, is going to be stored on storage or some type of distributed network, or it's going to be worth absolutely nothing. So it's kind of either case. It's either moon or bust.
Yeah, it could be ubiquitous and throughout all forms of life, or yeah, it could just be another notch on the belt.
Yeah. So again, it's just like Bitcoin. It's early days. These are extremely powerful technologies that we'll see where they go. We see a lot of use cases, but we'll see where they go. It's open days. It's the Wild West, the open frontier. So let's dig for some gold or some storage coin in this case, and see what happens.
Yeah, there's lots of mining and farming to be done. So maybe looking a little more intermediate or short term, do you see moving out of these test groups and being, launched, as we'll say?
Yeah, like I said, the way we're doing this is, I guess people in these kinds of things are looking for kind of a magical date, right? Like, oh, launch, like it's all done. No, we take a very iterative process to this. We'll do, sometimes, 2-3 releases in a day. It's just a very iterative process. So, like I said, we're running test group C right now, and that will run concurrent with commercial launch. So people will be available to use the platform and try it out in some capacities, but we will and are working with specific people on using the tool sets for live production applications. And again, that will run concurrent, because that allows us to both focus on those specific use cases that people are actually using, but also say, okay, now we understand that, let's kick the tires over here and figure out what we can learn more via the test group. So always testing, always iterating, always moving forward. That's just the best way to do software.
Yeah, I like it. It kind of sounds like an apartment building that, like, on the top level, they're still building new floors. Meanwhile, like, people are moving in on the bottom, and then you're also installing, new sinks.
That's the way all large software organizations work and deploy software. You look at Facebook. There's not like Facebook 1 and Facebook 2. Like, they just make little tweaks to the interfaces over time, and people freak out about this one and like this one. It's just a constant iterative process. So that's the way we do it.
Yeah, I remember the flip out everyone had when oh no, it's not Twitter favorites anymore, it's likes. We got a question from Taylor, and then the Pirates are going to take over here soon.
Yeah.
Actually, it's Kiko.
Hey, I'm just curious how you manage updates and sort of this process of versioning your protocol when you've got sort of live data on the network. Is there, such things as Dogecoin hard forks? And let's say when you roll out an update, like how long does it take for everybody to pull that down? Does it get to like 80-90% quickly, or does it take months to get everybody on the new version?
So we use the generic semantic versioning, major, minor patches. So you can read about that more on Google semantic versioning. That's reflected in our releases. In terms of, we do occasionally make backwards incompatible changes as we learn, and we get people to upgrade as quickly as possible. Through the GUI, there's like a little tool that allows you to just click when there's an update, and we're working on simplifying that process, so maybe it'll happen automatically in the future as well. But generally, our community is pretty quick about updating and moving things forward. I don't think we have any hard forks or anything like that in terms of Ethereum versus Ethereum Classic, but we do have some people running some customized versions of the software because they like to make some choices about what types of contracts they accept and from whom. So it's a very open process. It's an open code base. People are welcome to try, to fork, to contribute. We have a large amount of very helpful community volunteers that push us forward every day in terms of testing, features, bugs, and we truly appreciate that from them. Yeah, we use generic processes in terms of updates, but generally there's only one storage network right now. I'm not aware of any other forks running as of yet. I don't know. We still have to like do a DAO, and then maybe it'll fork and there'll be a storage classic, or we'll figure that out later.
Oh, jeez. Cool. So I think that maybe wraps up all our questionings here. We got a little tradition on the end of the show here, and Sean, this is like your third time I think being on the show. You might be familiar. We do Bitcoin price predictions, and here, let me share my screen here. So we ask our guests and our audience members, what do you think the price of Bitcoin is going to be in 1 week's time? And it hasn't actually moved too much here. I think everyone in the past shows guessed 580 to 560 is probably one. But Sean, what do you think the price of Bitcoin is going to be next Saturday at this time?
I think it's going to be around the same, probably maybe a little more. Let's say 570 or something like that.
570. Oh yeah, $3 more. That's
what I'm looking forward to is there's possible of coin ETF by the Winklevoss coming up in a couple weeks. I think they're going to kind of move that forward. So we'll see how that goes. That would be a game changer in terms of Bitcoin. So we'll see where that goes. But it's stable. So I think it's going to be stable, a week from now.
Yeah. I think the other, if it's any correlation to the other traded fund, GBTC, I think it will be, something that shows how bullish, traditional investors are on Bitcoin. They just need, a proper means to actually invest. I'm going to probably say I think we got to consolidate a little lower. We got to shake out some miners. You know what? I think that kind of nudes the type of stuff like Bitcoin likes to jump on. So I'm going to say 530. Be a little bear here. Let's go to our live audience and see if we got some guesses. I know Jen, whatever she guesses, I got to put 3 zeros on it.
666.
600. All right. 666. Oh wow.
You guys getting rated?
Yeah, I think the cops are showing up. They know the pirate party's there. We got any other guesses in the space there? Kiko, Taylor, I heard you guys here tonight.
I'll go bearish, 520.
That was Kiko.
Yeah.
520. Taylor.
600.
100. Ooh. Cameron.
Feel a little bearish. I'm gonna say 4,000.
4,000. All right. You 4,002 cents, or you never know. It could be close. Anyone else in the space there? Some new guesses? David or anyone else?
542. Aaron.
For Aaron. Oh, nice. 542. Thanks for coming out, Aaron. We got one of our online friends. Cool. Anyone else, or let's maybe wrap this puppy up. All right. I'll take silence as a good indication. Sean, it's been a real pleasure, and I hope to speak to you maybe in 6 months again. We'll hear lots of good news. Maybe you can bring Kim on the show with you, or you let him know I want an interview, and then he's like, oh, they got this great show. These guys will drill you hard with questions, but you know what? It's a great time, and yeah, we're happy to have you out.
Cool. It was fun, like always.
Awesome, and everyone at home, thanks for watching. We hit 1,000 subscribers, so woo, yeah, and everyone else who doesn't subscribe, hit that little red button down below. It's pretty easy, almost as easy as getting a Storj coin and burning out your hard drive. All right, cool, and yeah, everyone at home, thank you for watching. We'll see you in the next 1,000 blocks.